take a look at complex numbers first before we get into the PowerPoint slide. So you should see the board. And we said before that an imaginary number is where we have a negative inside the radical. Like, let's say a -9, negative square root of 9, which would make it I square root 9, which would be 3i. Okay, that's an imaginary number. A complex number has a real part and an imaginary part. The real part is a real number, like 5 or 7 or 12 or whatever. And then you have a plus or not minus in between. And then you have an imaginary number like 2i. So together, this is one complex number. And it could be plus or minus in between. And so that's what distinguishes between a complex number and an imaginary number. Okay. Now you could always take this imaginary number and put a 0 in front of it and make it 0 plus 3i. Now that's a complex number. But most of the times we don't do that. We just leave it just imaginary. Okay. All right. It looks like Jalen has entered. Hi, Jalen. Your last name is Robinson, right? I'm going to take that as a yes unless you tell me otherwise. Okay. So let's get back to our PowerPoint slide. Okay, so we distinguish between imaginary and complex numbers. So here we have a complex number plus another complex number. So basically we just add. We add the real numbers together and we add the imaginary parts together. And same thing with subtraction. But with subtraction, you have to distribute the negative inside the complex number, which changes the signs of both real and imaginary part before you, and then you're either going to add or subtract based on whether the signs are the same, you add. If the signs are opposite, you subtract. Okay, let's take a look at this problem here. And here we want to add 3 minus 4i is one complex number. Now, a plus, and then you have a -2 plus 6i. Okay. And so I thought I saw somebody else trying to enter the class, but they'll just have to wait. Okay, so let's switch this to the board again. Or actually, I don't have a board. I just have paper today. Okay, so you're going to add, you have 3. This is a plus, so we're not going to change the signs. So you have a 3 here, and then a -2. So these are two real parts. And then you take the two imaginary parts, the -4i and plus 6i. Okay, so you have the two real parts together and you have the two imaginary parts together. So if the signs, even though this says plus here, the only thing that this is good for is to tell you if you're going to change the signs. Since this is a plus, these signs stay the same. And all I did was I just switched places with the minus 4i and the minus 2. I didn't add or subtract anything yet. So now this is a positive 3 and a minus 2. So these signs are opposite. So we're going to subtract this. And since the positive is larger, this will be a positive 1i. And here we take the minus 4i and the plus 6i. Since the plus, again, these signs are opposite, so we're going to subtract. Since the 6 is larger, the positive is larger than the negative, this will be a positive imaginary part. And so we're going to get 6 minus 4i is 2i. So we took two complex numbers, add them together, and we got a new complex number. And that's our answer. Okay. Any questions with that? All right. So, chat. Oh, I got to. Jalen, some people are trying to join. Okay. I don't see them. Are they still trying to join? I think they've already joined. I don't see anybody else needing to come in. No, we're all here. Okay. All right. So let's go back to our PowerPoint. And so that's basically an explanation of that. All right, any questions there? If you have any questions, speak up. Otherwise, I'll just keep right on going. So I'll take it there are no questions. Okay. So let's take a look at the next problem. Here we have, okay, looks like Malachi's trying to join. I'll get him in just a moment. Here we have a negative 4 plus 3i minus 6 minus 7i. So this is what we're going to, so now you should see the board. Okay, now what you're going to do here is you're going to distribute that negative and then put the two real parts together and the two imaginary parts together to get a new complex number. Go ahead and try that. And I'm going to let Malachi in. Hi, Malachi. Welcome to the class. I have you on the attendance. Okay, Malachi, we pretty much just started with continuing with lesson 1.3, and we started with operations with the complex numbers, addition and subtraction of complex numbers. So that's where we're at. And we did one problem already. So we did the addition problem. Now we're doing the subtraction problem. Okay. Any questions with this so far? Okay, so basically what we're doing here, it's like you're putting a 1 there, right? And you're distributing that negative 1. So this is negative 4 plus 3i. So negative 1 times 6, that'll be negative 6. And negative 1 times a negative 7i, negative times negative is a positive 7i. So all the signs change inside the second set of parentheses. So now we put the two real numbers together. So basically all we're doing is we're taking the 3i and the minus 6 and switching places. We're not adding or subtracting anything yet. So this would be negative 4 minus 6 plus 3i plus 7i. Okay, how are we doing so far? So -4 and a -6, that's going to give us a negative, right? But are we adding or subtracting negatives here? Well, if you dug 4 inches, right, and then dug another 6 inches, you will have been in the hole. Now you're in the hole 10 inches, right? So you're actually adding negatives. And here, so we've added the 2 real parts. Now we're going to add the 2 imaginary parts. So 3i plus 7i is plus 10i. And that's our answer. All right, questions there. Okay, y'all are quiet with Zoom, but you don't have to be. You can unmute and talk and ask questions. It's okay. All right, just let me know if you have any questions. Okay. Now, when we multiply complex numbers, you're going to get an I times I is I squared. But the I squared has to change to a -1. So anytime we get an I squared, you got to change that from imaginary to real. So let's take a look at the next problem. Okay, now we're going to multiply. So here we're going to use FOIL, just like we would with variables such as an x. So we want to multiply. Okay, and we want to multiply 2 minus 3i times 3 plus 4i. Okay, now there's a significant difference between this one and this one. Notice there's a sign in between, either minus or plus, right? This one's a minus. Whereas here, there's no sign in between. So when there's no sign in between here, you have to multiply, right? Okay, so let's take a look at our board. Switch it to the board. There we go. All right, so we're going to multiply the 2 first numbers like we would in any kind of FOIL. 2 times 3. Well, that's going to be 6, right? 2 times 3 is 6. So we multiply the 2 first terms. Now we're going to multiply the 2 outer terms. 2 times 4i, well, 2 times 4 is 8. So this will be plus 8i. And then we multiply the 2 inner terms, a negative 3i times 3. So that'll be negative 3 times 3 is 9. So that'll be negative 9i. And then negative 3 times a negative times 4, positive 4, right, will be a negative. 3 times 4 is 12, but you have I times I is I squared. Just like when x times x is x squared. But the difference here between I, an imaginary or complex number, and a variable is that I squared, we have to change that to a -1. So anytime there's an I squared, we've got to change that to a -1. So we're going to change that. Now we have to combine like terms, right? We got a plus 8i and a minus 9i. That's going to give us a minus 1i, right? Because the signs are opposite, so we're subtracting. Well, this is the only real number so far. So we bring the 6 down. 8i minus 9i is a minus 1i. And you don't have to put the 1, you can just put I. Minus, and then 12. Now we're going to change that I squared to a -1. So this is 12 times -1, right? So negative 12 times -1, negative times negative is a positive, right? So 6 minus I plus 12. Well, we have, now this is the part that students tend to have some trouble with. If they don't get this part, then this part kind of goes them off. Now what you do is you take the I, the imaginary part, and the 12 is real, and you switch them because you want to put them together. So this will be 6. The 12 is a positive, so that'll be 6 plus 12 minus 1I. So all I did was just switch the negative I and the 12 so that I put the real numbers together. Well, we can combine 6 and 12, right? 6 plus 12 is 18. So that's our answer. We can't combine a real number and an imaginary number, so that's our answer, 18 minus 1I. So we took two complex numbers, multiplied them together, FOILed it, combined like terms, changed the I squared to a negative 1, simplified that, and then combined in like terms again. And we got 18 minus 1I. All right, any questions there? Okay. Let's get back to the PowerPoint notes. Okay, another thing is this is known as standard form. The real part is always first. The I, or the imaginary part, is always last. Okay, so that's known as standard form. Okay. All right. Now this one is similar to one we just did. Okay, multiply. Okay, we want to multiply 4 plus 3I parentheses squared. Okay, so share the board. All right, so here's our board. So we know, let's kind of set this aside for a moment. We know that x squared, right, is x times x, right? It's x times itself twice. So this is going to be what's inside the parentheses multiplied by itself twice. So it's like we're putting in a copier and hitting 2 copies. And so this will be 4 plus 3I squared is 4 plus 3I times 4 plus 3I. So it's this inside the parentheses times itself twice. Well, now we have to FOIL. Okay, so we're going to multiply the 2 first terms, 4 times 4, and we get 16. And then we multiply the 2 last terms, 4 times 3I, well, 3 times 4 is 12, right? So that'll be plus 12I. And then 3 times 4, the 2 inner terms, well, that's also 12I, right? So that's plus 12I. And then 3I times 3I, well, 3 times 3 is 9. I times I is I squared, just like x times x is x squared. So I times I is I squared also. Okay, so we're going to combine like terms, right? 12I and 12I. What's that going to give us? Okay, you should have said 24I, just like 12x plus 12x is 24x, right? So we're adding and multiplying the i's just like we would with variables. Plus 9, but the I squared, that has to change to a negative 1, right? So that'll be 9 times a negative 1. We change the I squared to a negative 1. Okay, so that'll be 16 plus 24 I. So 9 times negative 1, that'll be negative 9. Okay? So that I squared changes to a negative 1, and 9 times negative 1, that changes that 9 to a negative. Well, now what do? Well, we switch places. We want to get the real numbers together. We switch places with the real and imaginary numbers. So now this would be 16 minus 9. Again, we didn't add or anything or subtract anything yet. All we did was switch places. 16 minus 9 plus 24i. So now 16 plus 9, or 16 minus 9 rather, is what? You should have said 7, because 16 is more positive than 9 is negative. It's going to be a positive, plus 24i, and that's our answer. So we took our complex number squared, 4 plus 3i squared, put in a copier, hit 2 copies, FOILed it, combined like terms, right? Change the I squared to a negative 1, and then switch places with imaginary and the real numbers, combine the real numbers, and then we get our answer. Okay, any questions there? Alrighty. Continuing right along. Okay, that's our answer. Okay. Now, this is known as the difference of two, well, not yet, but they will be soon. I won't say it yet. Okay, we want to multiply um, 6 plus 5i times 6 minus 5i. Okay. So what do you think we're going to do here? Somebody? Derek, can you tell me what we would do here?
FOIL it.
FOIL. Good. That's right. So Jalen, what are we going to multiply first? Are you there, Jalen? Okay, how about Alex? Well, we're going to multiply the two 6's first, right? Okay. So we're going to multiply the two first terms, right? 6 times 6. And that gives us what? It should give us 36, right? And then 6 times negative 5. Well, 6 times 5 is 30, right? So 6 times negative 5 is negative 30. And we have the I, right? Because it's negative 5i. And then 5i plus 6, that'll be plus 30i. And then 5 times negative 5, that'll be negative 25i squared. Okay. So, Trent, can you tell me what we do now from here? Are you there, Trent?
Yes, sir.
Okay, good. All right, so we've got 36 minus 3i, 30i plus 30i minus 25i squared. What do we do with these 30i's?
I forgot what you
Do they
said. But
cancel?
if you,
Do they cancel out?
you cancel the odds out
Yeah,
because they the same.
they cancel, right? They go to 0. So that leaves us with 36 minus, and then the I squared changes to what? Let's see, Tanas. What does the I squared change to? Is it -1? It would be -1, right? Okay. Now, it's telling me I'm running out of time. If it looks like we all of a sudden get disconnected, go on to the second link. All right. Sometimes it gives us a little bit more time. So I'll finish this problem first. I'll see how far it'll take us.
I have a quick question.
Yes.
Does I squared is it always -1?
Yes. Always.
Okay.
Always. So I squared is all for complex numbers is always
Okay.
a -1. Whenever we're dealing with imaginary or complex numbers, I squared always changes to -1 because I equals to the square root of a -1, right? If we square both sides, that becomes I squared equals to a -1. Okay, so all we did is we took a negative inside the square root, and all we did was square both sides, and we made it I squared equal to -1. So these two are basically the same thing. Okay,
Okay.
but good question. So this will be -25 times -1 will be 36 plus 25. Well, 36 plus 25, right? I like to put one under the other. And 6 and 5, that's 11. And that'll be 61. So there's only a real part, right? So you could either say 61 or you could say 61 plus 0i. But most of the times you'll just see it as just 61. But it really can be written either way. Okay? Questions with that? All righty. Okay. Let's see how much we got left. Looks like we got a little bit left. See, and it shows you could write it either way. All right. So, and now we're going to get into what we call the conjugates.